Okay, so let's run a PDF toolbox. So basically, what we are running in tFLOW are basically pre-flight profiles. So a pre-flight profiles is technically a single file which is written with the XML languages, which contains a list of actions that we want the system will perform. Actions could mean different things like checks. Typical case is to check for image resolutions or for the presence of a font or for the document size, all these kind of things. Basically, the check is just triggering an alert if we set to be an alert with different severity. So in the case an event is happening, for example, is missing a font, we can set in the system to trigger this event as an information only, which is something not critical, or a warning. In this case is something medium. It means that probably the file can be printed, but it is something that is better we have a check on that, or an error. When we set the check to be triggered as an error, this has a different behavior in tFLOW. The reason is that when we define a check that is triggering an error and we upload this pre-flight profile in tFLOW, then when the system will trigger an error, then the PDF will be placed into an on hold status with the big red button. I don't know if you have any job in your instance that has triggered this. So let me check quickly if we have something on error. Yeah, you see you have a 7. So most probably you already have seen what happens. Is that okay, is this button, you see you have the status of the PDF is on hold. That means that the flow is stopped by actually. And the reason is that we have a severe error that requires most probably an action. Which kind of action is reported in the pre-flight messages? In this case, the reason is that the resolution is too low, and so that we have also an information about what is wrong in the PDF. So let's see the other side of the moon. So how we have to build this specific check to make possible that the system is triggering an error and putting the file on hold, like in this case. Which, by the way, is exactly the first point we have here. We will see the document integrity later. It's just a stupid thing, but is not so relevant by now. So let's start from the first check, which is alerting for low resolution, in the case this resolution is below 150. So to do this, we have to click on the Tools menu in the PDF Toolbox main menu and to select the profiles. Almost all the time we will work inside this area. So in this window, the system we will list all the profiles we have built in the system, which could be edited, just clicking on this button. In this case, the system will open the editor of the pre-flight profile, but if you have the full license of the application, you can also run the profile, the pre-flight profiles directly inside PDF Toolbox. This is useful when you're building your own profile to make sure that everything is working as expected. Because if you make a profile, you don't test in PDF Toolbox and you upload in the tFLOW, then you can have some unexpected behavior just because maybe your profile is not properly defined. So it's much easier and faster to be fixed inside the PDF Toolbox before uploading into tFLOW. This to make sure that everything is running properly. The main difference between the application when it is licensed or not licensed, this after the 2 weeks demo period, is that an unlicensed version of PDF Toolbox is still able to edit a profile. So even if the license is expired, then you can edit a profile. It means you can change whatever is inside. What you can't do anymore is to run the profile. It means, let me pick up a file, so I show you what this means. Let's run this PDF. Okay, when the license will expire, you cannot run anymore. So you can't run the pre-flight profile and have the results, like in this case. Okay. Okay, so let's see the first profile, which is containing just one check. When you edit your profile, you see that you have the window split into side. The left side is listing in a tree structure all the profiles you have defined in your system. You can group your profiles, labeling with whatever the name you want. This is useful, like in this case, to have them, you see, grouped by whatever criterion you are using. So for example, it could be production profiles, proof profiles, finishing profiles, or you can divide them by product types. So you can have a group called the product type A, B, C, and so on. And inside each group, you have all the related profiles for production, finishing, and proof related to that products. In this case, I have made a group called training. I show you now how to make a group. You see that here on this area you have the possibility to choose an existing group, but you can also create a new group. So creating a new group, you will go to assign this profile to this new group. Of course, the next profile which will belong to this group will be faster because you will have the group available in this list. So inside each profile in this tree, you have several items. The first block, starting from document up to convert to standard, are some predefined fix-ups and checks that Callas grouped here to have faster access, are the most common used. For example, in this case, you can check quickly the resolution of an image and setting to have an error if the resolution is below 150. This of course works, is much faster, but whatever you can define in this area is exactly what you have available in these two custom blocks, which are custom checks and custom fix-ups. We almost all the time works here. This because having all grouped here is much easier to be maintained and controlled at the second time. And the second reason is that working on this area will provide you the access to the whole list of the fix-ups and the checks, which here is just a limited section of this. Are the most common, but it's just a limited portion of this. So working here with custom checks and custom fix-ups will give you the possibility to access to the whole list. When I click on the custom checks, of course, this right side of the panel is contextually changing and is displaying me another two panels split on the left and right side. On the left side, I have listed all the profiles, all the checks, that are included, so they are active into my profile. Where on the right side, I have the whole list of the checks that are defined in my system. In this case, it is possible, for example, to pick up one check which is available in the list but not yet included in my profile, and clicking on this light left pointing blue arrow is possible to include. You see that I have moved from the right side to the left side. This means that now this fix-up, which is checking if the courier font is used inside Trimbox, is now included in the active list of my checks. Another important thing, you see that near the name of the check we have a red cross. The red cross is just showing us which is the current severity setting for this check. In this case, the red cross means that this check will trigger an error. We can easily change the severity of each specific check just clicking on the check name and using this selector. If I want to downgrade this check to a warning, level, I just have to click on the check name, and using the selector I can change it to info, warning or error. Again, when you set to error, this means that when triggered, this will put the PDF on hold. So what is more relevant here is to set on error or to set as an information or warning. Only the error is changing the behavior of the flow, the workflow in the tFLOW application. All the other two are just reported like in the case we have seen this way. In this case we have no warning, we just have one info. In this case because of transparency used. This is related to fix-up, but we will see this later. So going back here, you see that it is possible to make a long list of checks because I can select multiple checks and include all in my active profile, like in this case. But it could happen that, for example, if I want to include a fix-up, a specific check, that is not existing in this predefined list, I can create a new one. Because this is not the list of the all the possible checks that the system is providing me, but is listing whatever is predefined by default by Callas or whatever we already have created by ourselves in the system. To create a new one, I just have to click on this plus button on the bottom of the list, and now in this list, I see the whole complete list of the checks available in my system. You see that the list is very, very long, but we have this search field that is very helpful because entering a keywords here, for example spot, is filtering the list and listing whatever contains that word into the description. So in this case, for example, if I want to check if an object is defined in the with the spot color, I have this predefined checks. What I have to do is to click to add. Now you see that I have added this new check, and now I have to define the properties of this check. Of course, each check has a specific properties because in this case, for example, the system will check only if the object is defined with a spot color. So whatever we can define is to report an error or a warning if this condition is true or it is not true. And we can do this selecting here. For example, in this case, I have another check. Let me take away what is not needed. In this case, I have selected the check that is checking if the spot color names are consistent. In this case, there is any parameters to be configured, so the only thing I can do is just to add, and the checks will be ready to be used because there is any need to define anything. And depending on the kind of the checks we are adding, let me see if I can find something different. We can have different attributes like in this case. In this case, for example, we can check a specific attribute of the ICC color space, which are the tags included into the ICC profile embedded into the color profile, and then we can check for an attribute, and in this case you see we can define also the logic. For example, we can define a rule that is triggered when this attribute is equal to the number we enter here. In this case it's 3, and we also have the possibility to set a range ±1. It means it will be triggered for whatever is within a range from 2 to 4. So let's go back to our example check, which is checking for the low resolution, and let's see how is this defined. This is a predefined check. which is checking, of course, the image resolution. And you see that I have the possibility to define the properties, because in this case I need to have the possibility to enter the threshold value. We are going to create a check that is triggering if the resolution of the color image is lower than 150 ppi. So in this case, we have the predefined check, which is checking the image resolution. I set a rule that triggers the check in the case the resolution of the image will be less than the number we will enter here. In this case, this is the threshold value. This is an edit field, so we can enter whatever we want. And of course, changing this will change the behavior of the wall fix-up. You see that we have two checks in this case because we can combine them together. It means that this global check will be triggered only when these two conditions will be triggered together. In this case, the first one is checking the resolution. The second one is that we want to have more than 1 bit per color component. This is called the color image depth. So it usually is 8 or 16 bit for color images. In this case, we wanted to exclude the bitmap images, so we wanted to make sure that the system will check only the color images. So in this case, the bits per colorant or per color component must be greater than 1. Combining these two together will result in having exactly what we are looking for. So the system will trigger an error every time an image will be a color image and will have a resolution that is lower than 150 dpi. So let's see how this works. I have a sample PDF. This is an image which I downloaded from internet. So the resolution is the typical display resolution, which is a 72 bpi. We can check easily using Acrobat Pro. I click on image with the object inspector, and you see here that the resolution is 72 ppi. So let's run this check. So we drag and drop the PDF inside. You have to close this window as it will not work. Okay, now I have uploaded the PDF into PDF Toolbox, and I can run my profile. You see that the system is reporting the error because it has found that we have one image that has the resolution which is lower than 150 ppi, which is our threshold value. Another interesting thing running a profile that is containing check, which is also available in PDF Toolbox when you can download this report PDF, which is this one. In this case, our PDF is just containing one picture, and this is clear that if the check is triggered, is just one picture, so it's easy to recognize where the problem is. But the PDF can be more structured, so we could have several pictures inside. So it will be very helpful to also know not only that we have at least one image that has low resolution, but also to know which one is. And this is not only in the case of low resolution, but also for all the checks we have included into the prefile profiles, which another check could be missing font or font too close to the border, all these kind of things. To do this, let me run this again. PDF Toolbox is creating a so-called PDF report, which basically is also a PDF. Let me open it in Acrobat, which contains our artwork with highlighted the critical areas. You see that in this case the picture is masked with a red box, and if I move the mouse over, the system is reporting me also the reason of this highlighted area. In this case, the image is masked with red color because we have set the check to be reported as an error. In the case we have a warning, this will be masked with a transparent orange area and for information with a blue mask. In this case, you see, let me enlarge a bit, you see that we have reported the list of the errors here, and also moving the mouse over, it opens an annotation that contains the explanation of the error. In this case, you see that is clear which the reason is. The explanation of the error, which is the text you can read in the annotation tooltip, is something that we can also define inside the PDF toolbox, entering a description here. So whatever we enter here will be used by PDF toolbox to be reported here, in this case in tFLOW approval inside the pre-flight messages, but also in the report here in this tooltip. You see, I cannot select, but you can read the second line, which tells us the resolution of color and grayscale, blah blah blah. This is a text that we can customize. So in this case, for each check, we can define the reason and also the behavior of the checks itself. Let me close this and let's see the next one, which is another pretty common situation. In this case, we want that the system will alert us in the case we have submitted the PDF which has incorrect size. To do this, we are going to still use again the check functionality, but in this case, of course, with the different checks. Let me close this one and open the second one, which is this one. It's again a profile that contains again a check. In this case, we are using, of course, two different checks. Inside the global list, we have predefined checks that are checking for the page dimension boxes. You know that in a PDF we can have up to 5 different page boxes. So we have media box, which is the larger container. Then we have the crop box, which is the box that contains the bleed plus the space reserved for the crop box. Then we have the bleed box, of course, which is the live area plus the bleed. The trim box itself, which is the live area, and the art box. Art box is something that it is possible to be used, but is something that is going to be discontinued. In any case, this should correspond to the safe area. So it means whatever is relevant that must stay away from the borders. This is defined with Artbox. But Adobe, Callas, and everyone is suggesting to avoid to use Artbox. There is a technical reason, but it's pretty complex. For our needs, we don't have to use that one. So you see that, what we are going here is to check the live area. So we have two checks that are checking the document trim box width in inches and also the trim box height in inches. So we want that the system tell us which is the live area size. There is a variant compared to the previous check. You see that the syntax which we used to enter to pass the values to be checked is different. It's not a fixed value like in the past where we enter for resolution 150. In this case, we have a different syntax. The reason is that when we make this kind of profile, we don't know which will be exactly the artwork dimension, which will be varied depending job by job. So we cannot enter here something like 10 inches by 20 inches, because this, of course, will work only if the artwork will have this exact dimension. But the jobs can have different dimensions, so we cannot have here fixed values. We need to use a different approach. This different approach is managed by tFLOW and by CallasPDFToolbox using variables. Variables basically are simply placeholders that will be populated by tFLOW at runtime. That means that when you upload in tFLOW a job, independently from the dimension of that job, the system will grab the information scanning the PDF, like in this case, which the dimension is 925 by 12 or whatever. The system Dreambox is 9 by 12. The system will get this information, will populate two special variables which are called scale page x and scale page epsilon, and these values will be passed dynamically to the checks running inside the preflight profiles. This way we have a dynamic system to check the artwork dimension at runtime independently from the dimension of the document. Let's see how this works into PDFToolbox. So if, let me close a couple of tabs, okay. Let me take a PDF. In this case, I have a letter size landscape mode. If I run this profile, you see that the behavior is different. The system is now asking me which are the value we want to check for. So if I enter here the exact dimension of the document, which is 11 by 8.5, the system will pass the check without any problem because the dimension we have entered are exactly the dimension of the document. But if I run the same, but this time I say to the system, I want a final document which is 12 by 12, the system will trigger, of course, an error because the dimension we have entered are different from the current dimension of the document. This is very useful to have a document size checking in tFLOW, because in tFLOW you know that when we enter a new job, let me click here, let me simulate the new job creation. You see that here we have two special fields, which is print width and print height. When I enter a value, like in our example 12 by 12 here, these two values are grabbed by tFLOW and placed into those two special variables, which are called scale page x and scale page epsilon. It means that if I upload this profile, this will work dynamically. The reason is that the syntax we have entered here using this name convention, which is scale page x, is managed also by tFLOW. And tFLOW is getting the value you enter here and is populating those two variables with the value you have entered in the system here. This way we have a dynamic way to check the size of the document. Of course, if we build properly a profile, like in this case, this one. So what happens when I run manually in PDFToolbox, like in this case, where I have to enter manually those target value, this is managed automatically by tFLOW, getting the value from these two fields. So the end of the story is that if I upload this preflight profile into tFLOW and then I enter some values here into the system, then the preflight profile will get these two values and will check the document size, so the trim box size of the document that the user is uploading, against those two target values. If they are matching, there will be a pass. If they are not matching, the system will place the PDF again on hold, reporting an error which is described by the check itself here, which will tell us that we have a size mismatching. So or whatever we have here. We can enter a different description here. So in this case, we have seen a different approach on building a check, which is more dynamic. We have not so many predefined variables currently. Another one is to check the resolution, because we can combine the size dimension together with a resolution. So we can build a specific profile that not only check the size of the document but also the resolution. So we can combine together dynamically. The difference between this way with what we have seen at point 1 is that the previous profile, this one, is working, but it has a fixed target threshold value for the resolution. So if I upload this profile, this will work, but in any case the resolution will remain 150. If I want to have the same but dynamically, then I have to build something like with the size of the document, like in this case, using a different variable, which is called mean DPI resolution. And in this case, that variable is populated with the value which we will enter here. So in the case we wanted to have 80, this value will be passed dynamically to the profile and the profile to the check, and it will be used as a threshold value. So in this case, you see that the behavior is the same, but the way we are controlling the threshold values is totally different. This is dynamic, whereas the previous example were using just a static value. Is something that is working but is using a fixed value, like in this case, whatever we enter here. Okay. I know this can look a bit complex. I know it's not trivial, but it's just matter to be a bit more familiar, and then I am pretty sure with our help that the things will result easier. So don't be scared. I know the first approach with this technology is, wow, it's complex. It is complex, but it is extremely powerful. So it's like using Illustrator. If you start to approach Illustrator from zero, yes, it's very complex to be used, but it's very powerful. So it's just matter to have a fast learning curve. We are here to help you in doing this. So let's see another example. In this case, we wanted to check if an object is using RGB color. So to do this, I go a little bit faster because the way we are building the profile is exactly the same, but in this case, we of course are using another checks predefined in Callas, which is telling us if the object is using RGB space color. In this case, we want that the error is triggered if the condition is true. So in this case, I just picked up this predefined check from my complete list, and I selected this is true in this selector. I gave a name to the check, and so let's see how this will work. So let's take a PDF that is containing an RGB object. Let's take a test form. Let's check we have at least one object that is defined in RGB space color. So with my object inspector, I can go, where is an RGB object? Don't tell me that I have converted. Let's take another example. I think I have overwritten this one. Okay, just take this one. I am pretty sure it's RGB. So I run this. Okay, again you see that in the same way the system is reporting the error. In this case the reason is not because of the resolution, but it is because of an RGB image, which is the only image we have on the PDF. Is working exactly in the same way. Next one is similar. In this case we want to check the presence of the spot colors. Is working more or less in the same way. We have a check predefined in the system which is finding out whatever is defined with a spot color independently from which spot color is, just not CMYK. And we wanted to exclude the registration color to make to avoid that to have a false alarm, because sometimes the registration color is defined using a spot color. So combining them together, we make sure that the system will trigger an error reporting us all the objects that are using the spot color.